Question about the assignment?
Yes, you can let me go. Go there.
Oh, no, sorry. We would.
You can just stick your hands out. What's the question? 最 important part is I think the focus should be yourself as a person. You you assessment yourself. So the job is kind of like a source information where you get your knowledge. These are the skills. I don't think you using such as okay for this job I need to learn that and that and that. And for that job I need to learn that. I think the reason approach is to get several jobs and read about them, get some idea. So those are the skills that is most important. But the reason I think but you can like summarize your points. Yes. You actually okay. And your time might be likely that you didn't or that's because of subject. So I want to explain why you think I need to practice. Okay, I think that all this is the model that okay, so this microphone works when I don't want it. Okay, so this is a short list of well different realms um, and a list of some particular skills each of the realm a data scientist might want to look at. Lots of people are worrying about their mathematical skills. So let me talk it in this way. In this area, I think to get the entry level, not the graduate level, I mean entry level of PhD study, you will need able to be quite familiar with linear algebra, which will allow you to understand a large family of data models, including the neural network, which is very hot topic recently. You will be needing statistics. You do not need to go to too much in statistics, but at least you would be comfortable when people discuss discuss matters using terms such as mean, as standard deviation. You might, for example, when you read a mathematical, sorry, not, medicine publication, when the doctor is saying, okay, the p-value is this or that, uh, you may do not understand what is p-value, but when somebody explains that something to you, when p-value is equal this way, that means this hypothesis is so much unlikely to be something. You should be comfortable to follow this kind of discussion. So, well, then there's not very profound mathematics you will need to get into the field. But of course, when you encounter some real interesting problem, you want to solve it, you might need to study further. Okay. So similarly, I can see the discussion we just had about mathematics applies to programming. These are the requirements of those hard, I would call them hard skills. You need to be comfortable in programming. You shouldn't be fear of putting your hands on your keyboard just by clicking the screen. Generally won't bring you to but you do not need to be one that is with Linux kernel stuff like that. We use very straightforward programs. As far as you like to learn to program, that is probably fine. Okay. So programming. And the second part, I would like to call skill. Skills that is difficult to have some kind of standardized examination. After that, the people will give you a certificate. Now you are in communication level 5. Things like that. It is very important in this business. My research interests, okay, I'm very familiar with image processing techniques. As specific as this, you would find your customers, the users of your technique, really need somebody can communicate the real world needs and the technical solutions. For example, your customer would like to say, okay, this is a crankshaft. The crankshaft sometimes moves. When the crankshaft is stay put, don't move, then everybody can go around it, it's okay. But when the crankshaft is working, look, that is a frontal area of the crankshaft. The driver can see there, that is okay, safe zone. But at the rear part of the crankshaft is a red zone. Nobody goes in there. Okay, your customer describe problem like that. It is up to you to understand it in this way. Okay, I would like to come. We have a video sequence. In the video sequence, at each time point, I will have a two-dimensional array. Each array are numbers. Those numbers corresponding to the pixels in the images. And the customer wants the array, when the previous array and the second famous array represent a movement of the truck, then some trigger must be on. When the trigger is on, we need to have a look at this particular subset of pixels to detect whether there are some subsets of pixels represent human figures. You get this point?
Okay, so there is a large gap between real-world applications and whatever kind data models you will learn in school. Okay, so it's very important skill, and of course the communication, which means communication to people rather than communication between different field of uh, different format of the data or information. The communication with people is also very important. After you have developed your skill, or even before you develop skill, of course, you need to talk to people to understand their needs. After that, you need to get the selling point of your technique and present nicely to get you money. Okay, so that's very much of data scientist needs. Assignment one. Okay, now get to the interesting point. So if you have, give me a sec. I'm not sure if my screen share is still working properly. Hopefully. Hi, moving on. Screen sharing. I mean, for the online students, that's the screen sharing work. I'm not that sure. So if you have installed the software correctly, um, it would start like this. Uh, I have ignored a very important step. You need to create a new workflow. A workflow is like a blank piece of paper on which you can draw your plan of whatever kind of dealing with the data. You can start a workflow. Okay. It will ask you the name of the workflow, and the next step is to choose somewhere to store that. I believe when first time you open this app, it will ask you a location on your local computer where it will treat as local to store all your projects. Okay. Um, can we create a new project, every one of you? Let's go around and make sure we go. Oh, for people who take tablet or mobile to participate in this class, unfortunately, tablet does not, mine does not work with tablet right now. So you need a laptop to, to do this. If you choose to use the Python, I think for now the good idea is to use Colab. So I will go to Colab. New notebook. So the URL is colab.research.google. You can create a new notebook. Then you're done. Obviously, as any this is to execute the code. Fine. It needs some time to start the back-end processing kernel, but it will work. Look, hello world. Done with your Python or 9 setup. You have done this subject before? Yeah. Yeah. But you need to know what you are doing, right? If you do not have 9. That is so tricky. Okay, you look like someone who knows what is it. So the 9 part and then 1. Wrong. Okay. Let's start working with playing with that. The first step is, of course, put the data on table. So I have saved the example data, which is just not just a spreadsheet file somewhere on my hard disk. 9 is able to talk with XLS spreadsheet. All you need is something called data reader. There are a lot of different kinds of readers. So instead of, sorry, excuse me. So a short introduction of the work interface of 9. Basically, we will pick up something from here. These are our tools. These are the template of components which will implement themselves as working um, modules in the data analytics system. So we'll pick up nodes here, representing different processing steps in the data analytic models. So let me find something that allows us to work with XLS files. And this kind of nodes represent our idea of bring the data on table. It can read all different kind of data. So I think you do not need me, somebody or anybody to teach you what reader we need here, right? Okay. We will use an Excel reader. The next logical step is to tell your reader where to read the file. You can just double click it, or you can right click it. In a Mac, you use Control click it, configure. So there's a lot of stuff you can adjust for this step, but you can leave pretty much everything default, but provide it with where to find your data. In my case, is my desktop. That is bad. Oh, sorry. Because my desktop is managed by iCloud, so this 9 does not work very well with exploring the subsystem with desktop. I move this around, okay? I move this to my desktop. See how that works. Okay, this time it finds it. So move the data. Sorry, this is only particular to my computer because this new version, I just updated my 9. This new version of 9 does not talk too nicely with iCloud service. So anything on my desktop disappears from my 9. This shouldn't be the case on your computer. But on the other hand, I'd like to emphasize that this seemingly very simple step is one major barrier if you want to program rather than use GUI-like interface to deal with the data. You must be very particular about what tool you want to use, which means in programming world, what library you will import to your program. And those libraries might have very similar or the same name, but located at different places on your local drive. And where is the data, and where is the output folder you want to see the result. Okay, so in this case, we don't worry too much. We just click this, and you will find it has loaded the content of the data here.
Some people loading the other data set, they own data set, maybe we can show them just one of the same data set, so it will be the same page. Iris
Yes.
data set.
Yes, you can, but I don't. Yeah. So, then now this is our first step of exploratory analysis. This step cannot be easily substituted by machine. So, no, you can keep your mind peaceful. Your job won't be easily substituted by AI agents. Look at the data. The first impression is there is something wrong with that. This, when we store the information in an Excel file, this should be the name of the columns. This should not be the this should not be counted as a special content of the column. These are names. So in this case, you need to exclude the name of the columns from the contents by specifying the table contains names, which you should not count them as contents. Refresh it. Okay. Now the stuff looks normal, and if you note the type of the data becomes D. I believe D is a legacy term, which is called double precision float number. Anyway, you can consider it as real numbers. While these columns is the string. The string contains the name of the sample. They are flowers. Okay. So let's have a look of the data. Visual exploratory. Okay. Let's get. If you click plot, all different kind of plotting. So what we will use is a scatter plot. This is a little bit different from the JavaScript plot. JavaScript provides you a JavaScript which is a bit slower, but may provide you a little bit more functions. What we will use is a non-JavaScript, a local scatter plot. If you link this to this, you will find some very intuitive but not hugely interesting visualization of the data. By execute the endpoint of a workflow, it will automatically figure out what in the previous steps it needs to execute. Okay. Have a look. Get some impression of the data. The data points distribute in a space like this, but there is not much information from this looking. It's just interesting looking. Or maybe differently. Look, you can select appearance here and adjust the size of the plotting. Okay, a little bit more clear. what can you observe? What can you make out of this observation of the data? Perhaps they form two clusters. One is left up there, one is right down there, but this cluster looks a little bit more crawling out than the other. Hmm? Might be, okay. Because for this data, we know the answers. We know the class names, right? So a good idea is how about let us color those data points using their specific classes. So if you search color here, to have a color manager. There's a color manager here. Okay, we delete the link from here. Bye bye. I'm sure I'm deleting you. Link it here, link it here. The painter asking you what kind of color do you need me to use for each different species. Maybe I would choose a more differentiable color. Okay. Then execute again. How about this? It turns out the cluster that looks more complicated, actually a mixture of two species. Okay. Any questions so far? Yes, it's do you have a computer? Okay, I don't need. Sorry. Let me log in this computer and use this computer.
you can let them share their screen. If they can share their screen, you will be able to figure out.
Okay. Has anybody realized that this is some perspective of the data? One perspective of many of the data. Someone give me an interpretation of this, or maybe remember when we look at the data has this is the information in the data. Each data point has 4 attributes, has 4 numeric attributes and attributes and a class membership. So if each sample has 4 attributes, how comes the scatter plot arrange them in a 2-dimensional plan? So obviously we have discarded some information. This is like it's very difficult to imagine 4-dimensional object because we are 3-dimensional creatures. But you can appreciate the issue. If there is a 3-dimensional object, you are limited to 2-dimensional projection of this object to some piece of paper. You look at it this way. Okay. Obviously, you have ways to look at it this way or look at it from this side. So the scatter plot also allows you to pick which way to look at the data. If you click column selection, so look, those 2 axes correspond to sample length and sample width. On the other hand, you might choose other view of data which change the distribution of the data points immediately because they are now in a different 2-dimensional space. So if, for example, our aim is to figure out a model, remember our very particular definition of the model. The model get the input of whatever is available of the data and output whatever is of interest but unavailable in test stage. For example, in this question, we might say, okay, the sample length, sample width, the appearance measurement of a flower is available. It's reasonable when you go to the field and take a flower in marriage. Okay, what is unavailable is species. That is your task. It is your task to tell if this iris flowers, some setosa, what's the name of the, okay, what different kind of species. So the model's job is to takes in that 4 numbers and output one answer. You can call it A, B, or C, or you can formulate it more sophisticatedly, whichever. The output could be linked to one in 3 species. So by looking at data from different ways, you might be able to figure out what kind of those measurable attributes is useful for the predicted task and how it is to contribute to the predicted task. For example, in this very simple view, you might think perhaps the X column is the pedal width. If the pedal width is less than 0.7, I don't know the centimeter or inch, whatever. Say we can cut it in this way. If the sample length is less than this, we call it green space. Otherwise, we need to work a little bit more closely to figure out how to separate these 2 species. The art of data analytics is for you to roughly observe the distribution of the data and figure out what family of model is mostly suitable or is likely to be working on the data. Those particular model itself should be built automatically for us. Rather than, okay, I have a proposal, how about let us separate different species according to the sample length, and then we separate these 2 species according to that or whatever kind of complicated mathematical equations. No, you don't. You look at the data, and then, of course, after the study, you think, okay, this task perhaps should be manageable by decision trees. Then how about let us build a decision tree to classify those flowers? Okay. So we are going to do this right now. If you cannot follow, don't worry too much because we have a whole semester to figure out the details. I do a decision tree. What you will need is a decision tree learner. Learner does the job as what we have been looking at the data and do in our mind. You can call yourself an armchair decision tree maker, but this is a real decision tree maker. It looks at the data and build a decision tree that's suitable to classify the data. We will get into the decision tree predictor very soon. Before I do the next step, I need to give you a caveat. I will like to warning. What I'm doing in the next minute is exactly the criteria of getting 0 mark in your assignment 3. Don't follow literally what I'm doing. This is not a criteria. There is a very important missing step here. We will talk later. Okay, to build a decision tree learner, we link the data to the learner, which means you tell a decision tree learner, look, this is the amount of data. Those piece of information is what you can observe both in training now you are learned. And when you are deployed, when you are putting there, be put there, working. And this piece of the information is the target. So the class column means what is the target? The rest of all the other columns are the information the decision tree can use to produce prediction about this column. You can execute that. So what is the output of a decision tree learner? Of course, it's a decision tree. Well, let's have a look. What is a decision tree? A decision tree is a tree of decisions. Of course, it's an upside down tree. The root is here, and you go into different branches. At each of the node of the tree, you make some decisions about the data. Look, the learner has output. Well, in the first step, let us examine the pedal width. If the pedal width is less than this value, below this value, it becomes to Satosa. Okay, if it is greater than this value, it is not finished. We have a mix of classes, 50% vesicular, 50% virginica. So we need to make further decisions. That is according to pedal width. So you get the point. The tree, what we have learned out of this model is represented in this workflow figure in this little square. Consider this is the summarization of all the knowledge in the data, which we will be put in use for future prediction tasks. So we will need a decision tree predictor. Let's see, just to see a predictor. A decision tree predictor, of course, has two parts of inputs. For one part, a decision tree predictor use a decision tree to process data, make decisions. It use what? Decision tree. Okay, you need to give the tree from the learner to the predictor. And predict data. Okay, look, this is exactly the zero mark link. Don't do this in practice project. This is just for example, see how a predictor works, okay? Then you can let it execute. You should have classified data. So that is the output of the predictor. Well, for the first sample, species is Satosa, you predicted as Satosa. The second example, the species is Satosa. Good, correct. Okay, for whichever is in vesicular, it is predicted vesicular. Oh dear, it has an error here. But for, yes, the vast majority of the data is predicted correctly. right? It makes some mistakes, not too many. We consider the mistakes later. So, good. So my question is, uh, who can tell me, I have warned you several times, this is not the procedure we would like you to learn from this subject. What is wrong in the procedure? Give the data, learn something from data, and then do some evaluation to check to check whether the learned model works. So what's wrong with this? Yeah, exactly. Sure, that's the point. With that, the business of data analysis is because we want to learn something from past experience and want to use what we learned for future predictions. But this procedure represents we learn something from past experience and then we apply the model to the past experience. For all those data, if you already know the correct answer of the prediction, what is the point of the prediction? The evaluation of a learned model on what it had been learned from is irrelevant. It's wrong. So a very important step we must introduce is to split the data into two parts. I believe it is called partition. The technical term is partition. Partition. Take this into here. So instead of giving nice. I didn't realize we can do this. Okay.
No, he didn't. No. But now he's very quiet. He's very quiet.
Like this. So if you click the partition, so for what is relevant now is how much of the data you would like use to train the model and how many you would like to withhold, not allow your model to see and evaluate the performance of your model. So accept the default setting for now, 70, and draw randomly. So that's it. For the first part, the majority, 70%, you send it to the learner. For this, you send it to the predictor. Okay, put this aside. So we had in the previous step, we had manually checked whether the predictor's prediction agree with the known answer. What we can do is to have a quantitative measurement, such as a scorer. Okay, so we can execute everything. Huh? Should be able to.
Wait. Okay. So let's check what we got from Scorer. It uses a metric, a specific metric called the confusion matrix, which is none other than just a technical jargon. This matrix lists all pieces of you have mistaken some species for some species else. For example, in this row, it's saying when the species is Satosa, there are 15 such samples. Of the 15 samples, you all classify them correctly as a Satosa. You haven't classified any one of them into vesicular or virginica. So when the species is vesicular, you have all classified them as vesicular. When the species is virginica, you classified 9 of them as virginica, but sorry, you have misclassified 4 samples, which is actually virginica, but you have classified them as versicolor. So. There might be some ambiguity when it comes to the term test data. Look, our test data, we often call, if you want to call it not so formally, you can call that fake test data. For those data, you also have the answer. They are tests, they are classified, they are called tests here only because we choose not to use the answer we know, we have already known when training the model. Look, the answers of this part of the data is not available to the learner here. The learner depends solely on part of the data. Those answers is not available to predictor as well. Although the predictor receives them, but the predictor does not use the answer. Otherwise, there's no point of predicting. But the answers is used in the scorer. So the predictor pass the ground truth classes to the scorer, so the scorer can compare what is known, what is the answer, and what is the prediction, and produce the confusion matrix. Does that make sense? And in real world, there is true test data, test data, for which you do not know the species. It is like you go to the field and pick a flower, an iris flower, for which you do not know the species at all. That is a true test. So let's look. If we have time to look after our Python people a bit. Okay, sure. I think we have a small amount of time to have a look at if we can do this kind of task in Python. No, you are not ignored. The design philosophy is like that. for the early hour, the time between 8 to 9, it is designated to answer questions. Especially, I would like to stay here to answer questions about Python programming. From next week, you can come early if you are a Python person. And for now, I'm showing you. I don't know how many people decide to start using Python from this subject. Okay, and for the others, you have already get experience using Python. If you have experience, you might, you probably have the realization that in most of the cases, you code by Googling, right? So look, I improvise this demonstration. I didn't do that before. Let's try to perform this kind of data analysis task using Python and Google. Okay. I'm going to the Colab. Colab provides a very, very much overlapping set of libraries or tools as Anaconda. So it does not matter too much as far as this subject is concerned if you use Colab or Anaconda. Colab provides you also powerful computers, but you do not need too much computational power in subject either. Import. The import in Python is very much like the dragging node into the workspace inline. So the library we will use is called Scientific Learning Python. It's called scikit-learn. Okay. But actually, we do not need all the libraries, whatever, a lot of functions in scikit-learn. What I would like to do is from scikit-learn dot tree import look, you can just type the first few letters and it will do the rest for you. Decision to classify. Good. From scikit-learn.data says import. I think we have a function called, oh, I'm typing on good, load iris. Wow. I'm fast, okay. So nicely, because iris data is very popular, is a kind of, well, hello world in data science. So a lot of learning tutorials use that. There so much so that scikit-learn provided by default. You can see, okay, iris DB root iris. Isn't that it? Add a code. So look, this is not strictly linear programming. You can do a little bit try and error in one block, and then you open up another block, do another piece of job, and then you are happy with the outcome of the execution of the code. Now you have the iris DB. So using a Jupyter notebook, an advantage is for whatever thing you do not know, you can just execute it to let it present itself. You get the impression. So although it looks very differently from 9, the essential information is perfectly the same. Look, in the RDB, you have data, and data is the array. The array has as many as number of samples of rows, and each row it has 4 numbers. Now you get the idea, right? So then where is the class names. Okay, target. So because it is categorical, it does not matter if a class is called 0 or it's called Satosa, right? Or it's called A, B, or C. Sure. Now we are concerned with two pieces of information. Dot data C. Works. X looks right. Y looks right. So let's do the dirty quick sanity check without splitting the data into two parts. Let's just quickly learn a decision tree classifier out of this data. Okay, say consider itself is not a decision tree. If you have ever learned Java or C++, you may have the concept of what is a class, object class. Object class is like a blueprint out of which you can make object, but itself is not object. It is like the node on the left bottom side of 9. Those nodes are node templates. To use this node, you need to drag the node into your workspace. Okay. To implement one object, can do this, dt, this. So I know the name of the function, but if you, for example, if you don't know, you can see this and put a directory out of that, which is which lists all the possibilities object provides you, but even more convenient way. In Jupyter Notebook, you can just type a question mark after a variable, then it will search its own document and give you very useful information about it. So I know I will use the fit function. If you don't know how to use the fit function, you can also question it. Fit would be used in this way. Okay. Now we have a decision tree. This is a decision classifier that's been built out of the whole set of data. Let us use it to predict. So this is a prediction of the decision tree. We can compare it to Y. If this prediction is equal to what is known as ground truth. Okay, most cases. True, all true. Okay. So quickly, we use Python to build below the data and out of the data. We build uselessly correct decision tree. Okay. So I think in the next week, when I'm doing the consultation, if you are interested in using Python, I can help you to do the proper split of the data and manipulation. So I think that's it for today's class. Thank you for coming. Welcome. Yeah. Could you let me end because we have another group of remote people.
Next class. Good job, John.
See you next week.
See you.
I just want to ask.
Let me say goodbye to
Okay.
the online group of people.
拿号码吗？
啊，我也不太
预约
清楚，
挂好的。
应该是在这里吧。
To set up my online.